Glad to be here. Thanks for joining the session. My name is Mustafa. I'm an Android developer at Reva. This session is about the passwordless apps with the passkeys. So yeah, let's get diving. According to some kind of statistics, you can find based on FIDO Alliance that 81% of the breaches that happens for the passwords because it's weak. So this is one of the reasons why maybe we should consider passkeys in the future or starting from now. Also, some interesting thing, or one of the interesting statistics say that 34% of the people reset their password once per month for some websites. And who don't know, like, what is a FIDO Alliance is? It is like an association for like some engineers from well-known companies like Microsoft and Google and Apple. So they are trying to make the reliance on the passwords less and trying to push the people to use the passkeys in the future. So, passkeys. So the first question we ask, what is a passkeys? What is the passkeys in general? And this is a good question. And we can say that the passkeys can be, I think, we can summarize it in these 4 points. It's a password alternative, so you don't have to use a password anymore. It's used for the sign in and also for the sign up. And you can do that without writing any password, definitely. The passwords or the passkey, is using the biometrics or any screen unlock. So if you have also like an old device, you still can use the passkeys using the smart or the screen unlock. The passkeys in general is stronger and is like reducing the phishing attacks that happens maybe with the passwords. And the last point is it is a public key cryptography, so passkeys totally depends on the public-private key cryptography. So the second question, why the passkeys is safer, why it's better, why it's easier to use, because after applying the passkeys for some companies or some systems, they found that 95% reset passwords are less. They found that 4x times in the success rate on the successful login. So because they don't have to write passwords anymore, so that's why it's become 4x. 75% definitely reducing the time because they don't have to spend a lot of time maybe to writing the password, especially if it's like a complex password. And also why it's easier and also why it's cheaper at the same time. That's also something we should consider because you don't need to consider like two factors or multi-factor authentication because some of them maybe require some kind of license. And you should also, no password should be sent to the server. So you will never send something, if even the password if hashed or something like that or encrypted, you don't need to send a password anymore again to the server. So let's get started and go deeply to the passkeys with the first step, which is digital asset linking. Most of the people maybe who are going to use a passkey in the future should have like an existing app or an existing website. And somehow you would like to declare that I am the owner of the app, at the same time you are the owner of the website. In that case, you have to create an asset link.json file, because that declares that you're already the owner of the both. So before you're getting with authentication or registration with passkeys, you should create this file. So this file is responsible for sharing some kind of credentials between the website and also with the app. It's pretty easy to create that. So it's just a JSON file. You have to create it in your maybe local computer first, locally on the computer, and you have to place this file on your domain. And especially it should be inside the domain or the directory, which is .wellknown/ and asset link.json file. Why we are doing that? Because also this is important because Google should be permitted to access the asset links file and establish like the relationship between the app and also the website. So this step is crucial. We cannot do anything without this digital asset link. Here's how it looks for the asset link file or JSON file. The first thing is the relation. This is just give us, as you can see, maybe in the second line, the common.get login credentials. It's just sharing all the credentials that you already have to the device. So you just give an access for mobile to the website or to the credentials you have. And second, you can find like the namespace, and this is the target you are targeting an Android app. And this could be also changed to web. But since we are targeting that we would like our app to access the credentials, so we should add like Android app. This is pretty straightforward. This is a package name of your app, and the last also pretty straightforward for the fingerprints or the fingerprint of your certificate of your app. So, passkeys in action, this is also important. So, the first thing we should consider is use cases for that. So, based on the UX, we have like 4 use cases for passkeys. 3 of them considered as registration, and 1 is considered as a sign-in. The 3 for the registration is sign up. So, if you are a new user, you would like to create a new passkey or just create an account. So you would like to create a credentials. In that case, this is a sign up. If you're already an existing user and you would like to create that while you are like interacting with the app, so in that case, you have to go to the settings or the account settings where you can add the option to add the passkey. The third, which is considered as well for registration, is the account recovery. When you are recovering your account, you should also consider to add this kind of option to the users just to be able to create, because you would like to motivate them just to make these passkeys in the future. The only one, which is the last use case we have, which is sign-in or the authentication. And this is pretty straightforward because you already have a passkey and you just want to authenticate yourself. To start working with the passkeys in our Android Studio in general, passkeys already supported using the Credential Manager API. So yeah, don't forget to add this because otherwise you won't be able to work with passkeys in Android. I would say the architecture should contains all these components. The first component we have is a backend, and we can name it like relying server or like party. Based on a web auth, and this is maybe the name of it. So this is considered like backend, this is considered like a server, you can name it whatever you want, but this is something related to the backend more. The second component is the app, this is typically your app, so nothing is fancy here, so it's just normal. The credential provider, this is important. Credential provider it saves the passkeys, and also it creates like the public and private key. And you can consider the credential provider as maybe Google Password Manager or any password manager software you have. So it's not limited for Google Passwords Manager. It also can be available for other password managers, because also there is a credential provider API for that. It already exists as well. And as we mentioned, this is the Credential Manager API because we need that, and they work together. The Credential Manager API and the credential provider, they are working very near to each other, and they are transmitting a lot of data together. So we can consider them as a one layer because they are transmitting data a lot of, many times. And we can see that during the presentation, we will have like some use cases, and we can see how can they interact together. The last component is the authenticator, and as we mentioned, the authenticator not only like a biometrics, but also could be a screen unlock. So, as we mentioned, we have registration, we have authentication. We're gonna start with the registration first. So, registration, as you can see, when the user intends to create a passkey, he sends like a username. For example, I'm just like a new customer, and they would like to add a passkey for my as a login credentials in the future. So in that case, the user can send you like a username. Username maybe here's like an email or something like that, or something maybe special, for example, like username or like Twitter or something like that. Like you have like identifier, we can say it like that. So when you add that, you can see on the left-hand side, you can find a screen on the left. You can find the name you already added, and also it's shown. Like I'm not sure if it's clear or not, but the Google or the Gmail is already mentioned here because the passkey should be stored to this Gmail account, okay, or to Google account. So when the user click continue, he will be asked to verify or to authenticate that he is the owner of the phone, so he can maybe do that with any kind of authentication, authenticator that the device is providing. So after that, this is the second step, and this is the last step. After that, the user can be logged in, and you can see that you already logged in and the passkey is already created. Definitely, we would like to know and understand what happened behind that, because that's maybe important. Based on the architecture we just talked about, as we mentioned, the first step, the user is intended to send the signal to the back end, just say, hey, I would like to create an account. In that case, you can also, as we mentioned, we can pass the username. So requesting this or sending the signal to the back end start its job and try to create something public credential option object, or yeah, this is an object. This is also like a credential manager API object, and this including something called challenge. And challenge is something maybe we have to talk about it like in the next slides, because it's also pretty important. So after creating this public key credential, this object should be sent back to the app, and the app should send that to the credential manager API or the credential manager API or credential provider library or layer. And why it's doing that? Because who is responsible for creating the public and private key is the credential provider with the credential manager API. So this layer is responsible for doing that. So after this layer like received this object, which is the public key credential option, it creates like a private key, and this private key will never leave the app. It should be stored inside the device and never leave it. And the public key should be sent back to the server for the future login, for future authentication. However, you can maybe ask yourself, is it secure to send the public key maybe to the server? Maybe any attacker can intercept this request and maybe catch or capture this public key. It's fine, it's called public, you can share it, so no worries, because if he has a public key and he doesn't have a private key, it's useless. So he should have both of them, just to be able to grant an access. So after requesting the new registration, we just send that to the server, and the server, which is our relying party, is verifying this, because if I'm sending a challenge, and we're going to talk about this as we mentioned, like for the next slide, I have to make sure that for user A that I send a specific challenge, I should receive it back just to make sure you are the same person. But in the code, it would be much clearer. So this is the object we were talking about, like public key credential creation options, and this is like it describes how would you like to create your passkey. We're gonna see in a few seconds. So the first thing is the challenge. This is how the object that we receive from the relying party or from the server when we intend to create a new passkey. The first thing is the challenge. The challenge is a base64. It's just a random base64 URL, just like random characters. And this is responsible for avoiding any kind of something called reply attacks. A reply attacks is something like, suppose you have a token, for example, and this token is expiring after a week. So if an attacker already intercept the request or the response, we can intercept the request or the response from the server, and he can get this kind of token, he can have he can grant some access in the future with this token. However, the challenge is a bit different because it should be only used once. Once it's used, it will be invalid and it's not used anymore. So this is important because that's why we can avoid any kind of reply attacks. The second point is, or the second object is RP, which stands for relying party. This is just like a domain, the domain name or the domain name of your website or your server, and maybe the name is just an application name. And that's important why we should also pass this kind of domain name, because if you have a lot of passkeys for different websites, this key or this RB should define or should distinguish this passkey is for which website. So that's why we are sending that. The next point is, or next object or array is public key credential parameter, and this is define what are the algorithms that's already supported by the relying party. So just mention some kind of algorithms that you should use it maybe while you are creating your passkey. The next is authenticator selection, and it has something, as you can see, authenticator attachment. And this is it's like just configure how would you like to have your authenticator. So for example, the authenticators in general is just, as we mentioned, like parametrics, like screen unlock, and it could be also like physical keys, like for example, like YubiKeys, for example. So YubiKeys is considered as a cross-platform because you can use a YubiKey in different computers, you can different devices. Okay. However, if you said that, or you set it to platform as we set it here, that means the authenticator is already attached to the device, so it cannot leave. So that's why the authenticator is a platform. That makes sense because we would like to authenticate the user using his biometrics or screen unlock. This is the user object where we already sent previously, as you remember, we just sent maybe then your name, or also we can send the ID, but the ID cannot be, this ID is just a identifier from the server, so it cannot be something like, it's like also random characters, just like maybe like a primary key or something like that. And the name is the name you already wrote when you start your passkey registration. And the display name is maybe, the name maybe is a bit like identifier. For example, if you have like a Twitter, you should have like an ID for the account. So this is something. The second one is this display name, which is maybe different. It's not the same, but both of them you can send them. So the name and display name, you can start sending them when you start your registration for the passkey. So this is maybe the registration, maybe a snippet, and you can see that when we start, we just have a public key credential options, which we were talking about like in the previous slide. And we just have another function called start passkey registration. We just send this username. And we use, as you can see, the public key credential in the something called create public key credential request. We need this request because we're gonna send that to the credential provider just to create the passkey for us. So that's why you can see that there is something called also on the line, I think number 7 or 8, which is create credential. I will move just to make it like easier to find it out. Yeah, this is a request we just talked about, the JSON file we just talked about on the previous slide. The next is the credential manager.create credentials. In that case, when this is like a suspend function, by the way, and also when this is invoked, the bottom sheet should be displayed to the user. The bottom sheet you saw on the previous slides, it's just a native. You don't have to create it yourself because it's already created on the credential manager API. So if the user already press continue, in that case, we will create the passkey, and at the same time, we should retrieve an object called create public key credential response. And this response should send back to the server just for some kind of verification. But we should have some kind of also information about how this kind of object, which is the response, which we are going to send back to the server, looks like. This is the object that we're going to send back to the server. The first is the ID and row ID, just credential identifier because you already created, so you have a credential identifier already. This is just like a credential type. It's the public key, as you know. After that, we have something called attestation object. Attestation object, we shouldn't like go into that, but attestation object is just like if you'd like to make sure that the authenticator is genuine, and this is to improve or to make sure the integrity of this authenticator, you should have this response. You should send it back to the server because otherwise we will not make sure that okay, was the authenticator is safe or not. Maybe it's passing the integrity test or not. In that case, you need to pass the attestation object that describes how is authenticator, your authenticator. The client data JSON can it's just also included array buffer, just like most of the fields we send, but it contains different fields. The first is a challenge, and this is important because, as we mentioned earlier, that the challenge you receive when you start the registration, you should send this back just to make the server distinguish, okay, you are the same person. And also, it contains like the origin of your domain because it also should be matched to the domain, which domain here means the domain name or the relying server. And also the type of the request, because we have get credentials, we can get credentials, or we can create the credentials. This is the same attachment that was the same we just talked about it in the previous object we received from the server. The same about the platform and or cross-platform authenticator. So once we send this back to the server and the server already verified that, you can just show the toast message or the snack bar message that say that you already created your passkey. The next step for us is the authentication. Authentication is also following the same architecture and also following the same data transfer, we can say it like that. So you already have a sign-in. So when you click on the sign-in, you can find a bottom sheet. This also bottom sheet is already built in. You don't have to create it yourself. It's already also provided by Credential Manager API. So you can, maybe because here it's just like one passkey for this domain, you can have multiple, it's not a problem. You can have different passkeys for the same domain. So you can select, once you select or you press continue on that, you will be asked again for your authenticator, or you have to authenticate yourself, authenticate that you already own this device, and after that, you are logged in. The same architecture. First of all, we are sending to the server that we are requesting. We need a challenge because also the challenge is already also used in the not only in registration but also for the authentication. So in that case, there is an object as well is sent from the server to the app. So I think it's not that. It's fine. Let's go back. Okay. So when we send that, the app, we send back this object to the app. The app starts. It creates something like, as you can see, like public credential options is going back to the Credential Manager API. But that's also important that because the Credential Manager API is not limited to the passkeys, because it can also contains passwords, normal passwords. So in that case, you just return this object from the server because you said that I would like to log in, and you just receive a challenge to your app. So you have to pass this object, which contains the challenge and other fields, to your Credential Manager API just to start the authentication process. When you receive that, you select the passkey and you can authenticate yourself, as you can see on the screenshots. So when you receive that, you get some fields, these fields including the RB ID, which is the domain, or you own. And when you get this domain, you are searching inside the content or the credential provider for the passkeys that matches this domain. Because you can have different passkeys in different websites, as we mentioned. So when you say, I would like to log into that, you receive an ID or the domain from the server, and then you can search for that inside the credential provider. Just get it, and you can start the sign-in, and you can authenticate using the fingerprint or any authentication method. Just a last thing we should mention is the signature, this is pretty important. This is the core of the authentication process. We agree that we already received a challenge from the server, and we already found our passkey based on the domain we are trying to log in. But we still need to verify, or just sending some kind of verification, or you have to make sure that the user is a correct one, or he is the same person. So when he received the challenge, as we mentioned at the beginning, we have a private key already saved on the device, or in the device. In that case, this passkey or this private key should sign over this challenge. And when you sign the challenge with your private key, it's easy to pass this to the server because he already owned the public key. So when you return this back to the server and he has a public key, he knows that I know this person because this signature is matching one of the public keys that I have. So when we start to show some kind of passwords in general, we said that it's not limited for the passkeys, but it also has some kind of passwords. So when you start, you just want to get all the passkeys you have and all the passwords you have. So that's why the first thing is requesting. We receive first the challenge and other fields from at the beginning when we start the process. After that, we have the passwords. We can this get password option. By the way, this is credential manager functions. So it's not like something we created. No, it's something it already exists, so you can use it. And the get credential request. This is just an object where we should send it to a next method, which is I will show to you, which is get credentials. So you get the request. So the request contains two fields or two types: the passwords and also contains the passkeys. It's already wrapped in a single request. You just get this request and just pass it to the get credential. Get credential is also a credential manager method, by the way, also, and this is also responsible for showing this kind of bottom sheet we saw. So the first step, you get these passwords, you get the passkeys, you wrap them in a single object, and then you pass this object to get credentials just to be able to see the bottom sheet. Okay. So the public key credential request option. This is the first request we send when we are going to make the login or authentication process. This is the first object we receive. I didn't know. Okay. So the first one is the challenge, as we mentioned. This is also, as we mentioned, this already like a random characters. It should be used once, and after it's used, it's already invalid. This is the timeout of the process because it should be time framed. Otherwise, if it's already timed out as well, we have to invalidate the same challenge as well because the time's up. User verification is required. This is just a correlation that you need user verification for using his authentication or whatever. You would like to, because it's not only required, you can have other options. One of them is required. You can have something preferred or other things. There are three of user verification. But most of the time, I think we should use required because we would like to verify, or we should authenticate the user using his fingerprint or any option for the authenticators. This is the relying party we just talked about. When we receive the first response from the server, this distinguishes the passkeys already attached to this domain. So this object is called public key credential. It's not important, but this object is sent to the server just for verification process. This object should be sent, and it should contain the most important thing we just talked about, which is the signature of the challenge we received. We should sign it, and then we should send it back. This is included inside the public key credential. It also includes the IDs and the identifier of the or credential identifier, and authenticator data. This is also the data we just talked about. I think it contains a lot of information, including the relying party ID. The client data JSON, I think we already encountered this previously for the registration, where it contains a request, the challenge we already received, and also the origin and the domain, and a lot of things, maybe a lot of metadata inside this object. And after that, we have user credential, and this is just contain the user ID where we receive or where we intend. So if you have, as we mentioned, like Twitter or something like that, the user ID, when we send that to the server, you get it back. So you can also you can use it as one of the things you can distinguish between the passkeys you have. This is also previously like the same. The platform is the authenticator is already attached to the device, or it's like a cross-platform one. Cross-platform, not like it's not like Flutter or something like that. Cross-platforms, as we mentioned, it's like that the authenticator can be used in different places, or it's not only limited or not attached to the device. After we send this back to the server, and the server matching the public key he has already, because when you start the registration process, you just save when the user when you send back the challenge to when they're already. So we start from the registration, and you got the public key from the credential provider. You just send this to the server and save it. So when you have any kind of signature with a private key, you can verify that the public key and private key are the same, or they are key bearers. So you can verify the response from the device. So to sum up, maybe the passkeys in general and how it's, to sum up in general, we have the password. The passkey is safer because, as we mentioned, passkeys, you don't have to send passwords, you don't have to write passwords at well. So the phishing could be like maybe less because you don't have, as we mentioned, to write passwords or whatever. The digital asset link is important, and this is one of the first steps you have to consider, because when you start your app, you should give some kind of access, we can say, like for the device just to get the credentials or can communicate with the domain. The Credential Manager API is a base of the passkeys in Android. So you will never have passkeys. You will never have passkeys if you don't have Credential Manager API. Registration process, just trying to go through it like fast. The first step when you start the registration, you intend that you would like to start to create a passkey. So in that case, you send a display name, and you also if it's required, you can also send like a user ID. And after that, you send that back to the server. The server will start the registration process from itself, from the server side. You will receive a challenge. This challenge should be go back to the credential manager. And this object, not only the challenge, the object or the JSON object or that contains a lot of fields inside of them, like challenge and the user and a lot of things. This object is sent to the credential manager API. It creates, or the credential provider as well, because they are, we consider them at the one layer, and you can just send this information to use this information just to create a private public key. You should save the private key in your device just for the future authentication, and the public key should send back to the server, and you just will be signed up. The authentication is similar, but with different fields, and also, we can say like different fields. You start that you would like to sign in, so you can see the bottom sheet. This bottom sheet is not started unless you already get a challenge or also an object from the server, and you also get the passwords, and using this challenge or this domain you get from the server, you just go to the credential provider, just get the passkeys you have, you just get all the passwords you have, just show them or display them on the bottom sheet. The user can choose whatever he wants from the passkeys or passwords. After that, when you click continue, you should also use the fingerprint or any authenticator type, and you should send the authenticator and you should sign the signature. That's important. Sign the signature, and then you can send this back to the server. The server takes job that it will try to okay, I have a public key, and this is already assigned a challenge using a private key, so it can distinguish between the users. That's maybe basically how the registration and also the authenticator is working, and generally the importance of the passkeys. So also these are the reference. You can check this out. It contains like some medium, and also the last one or the last reference is pretty important, which is related to the WebAuthn and documentation. So pretty good if you had a look for these references, because it's very informative. And I would like to thank you all for your time. And thank you, and have a nice rest of the day. Thank you.